Okay, we're going to take a look at solving by substitution. Now, there are a few different ways of dealing with this. So, when we're going through and doing substitution, one of the things that students have the hardest time agreeing with, figuring out, is that one thing is equal to the other. Doesn't matter which one is which, we just substitute one in from the other. So if I want to go through and I want to do this and I want by substitution, I need to have a variable equal to something. Generally speaking, I want to pick on the easiest one that there is. Oh, I could solve for 2y here, I could solve for negative x here, I could solve for y here, and I could solve for the x down here. Now, the easiest thing to try and do here is to pick on a variable that has no coefficient and it's positive. So with that being said, I'm going to pick on this one right here. So I got y minus 2x is equal to 1. Add 2x to both sides, add 2x, and I end up with y is equal to 2x plus 1. Now, everybody always wants to think of that, oh, it's variable should be equal to a number. Y is equal to 2x plus 1. What's y? 2x plus 1. Doesn't matter. That's just what it is. So now what I'm going to do is I'm going to pick on the other equation. My other equation is 2y minus x is equal to negative 6. Now, since these are supposed to be together, wherever I see y, I know exactly what it's equal to. It's equal to 2x plus 1. So what I'm going to do is I'm going to take this information here and put it in here for y. So what you end up seeing is 2. Remember, whenever we replace a variable with its value, whatever it's equal to, those parentheses. The minus x equal to negative 6 is still there. Nothing's changed. What am I going to put in here instead of y? Well, that's where the 2x plus 1 goes in. Because y is 2x plus 1. Wherever I see y, I can replace it. Now, the reason that we want to go through and do this is because we know how to solve an equation that has one variable. So, questions up to this point in time. So, now that I am here, I'm going to go through solve. Now we got the distributive property. So that goes there, so we end up with 4x. This goes to there, so I get plus 2. Then I still have the minus x is equal to negative 6. It's still back there. So I combine like terms here and here, so that gives me 3x plus 2 is equal to negative 6. Yep. Subtract 2, and I end up with 3x is equal to negative 8. So far, so good? Does everything look like it's working the way it's supposed to be? And the answer is no, I screwed up. How did I figure that out? Well, I got 3x is equal to 8. That's a fraction. Yeah, we can get fractions in here, but I probably messed up somewhere along the line because it should be an easy problem to solve, right? Does anybody see what I missed? I took 2 times here. I got 2 there. Well, actually, no. I thought that was supposed to be a 4 here. I actually got everything. Right? Double check. Negative. Yep. Everything looks good so far. Copied it all down. Made sure of that. So, okay, then I guess I am on the right track. Sometimes it just does that. So we get x is equal to negative 8 over 3. Okay? After all, that's got to be what it is. Okay? Okay, so now that we're down to 8/3, what are we going to do with that? Well, just like I had done before, up here I knew what y was supposed to be equal to, so I was able to substitute that in and work with it. Now that I know that x is equal to this, I am going to go through and plug it in up here for what x is supposed to be. So that means that I get y is going to be equal to 2 times, so what was x supposed to be? Well, x was supposed to be negative 8/3, correct? So when I go through and do the math, I get y is equal to, we can put 2/1, so 2 times 8 is going to be negative 16/3 plus 1. Well, I'll make the one with the common denominator, so that would be 3/3 instead of that. So we get rid of that, so we get y is equal to, that would be negative 13/3. So that means that the coordinates for this thing are going to be at negative 8/3, comma, negative 13/3. The process isn't all that bad. You're just figuring out what one variable is equal to, taking that information, put it into the other equation. Figure out what your solution is there, take that and put it back into the first one. So, what that leads us to is this. We've kind of talked about this before. If we have lines that intersect, they have lines, the lines are going to have one point in common. We classify that as consistent. So the type of system is going to be consistent and independent. So what I'm going to do is I'm going to give you a few moments and make sure that you put that chart into your look. Yeah, so take a look at this. Now, that was nice, kind of them. They actually have variable equal. So what I'm going to do is simply replace wherever I see y in the second equation with it up here. So if I have 2 where the y was, is equal to 2x minus 4. I'm going to pop in what that was equal to, so it's going to be x minus 2. So now I'm going to do the distributive property, so I got 2x minus 4 is equal to 2x minus 4. Looks a little odd, does it not? Well, if I were to go and let's just say I don't see anything there, and I subtract 2x here, I subtract 2x here, I add 4 here, I add 4 here, what I end up getting is that 0 is equal to 0. Now, is that true? Yeah, 0 is equal to 0. Now, let's go back to here. If the lines overlap, they share all points in common. They are consistent and dependent. Okay? So these are coinciding lines. And how I know that they are going to be coinciding lines is when I did the math, or did the algebra, I end up with something like this. Now, there was something else I had talked about earlier. Are they multiples of each other? Is there a value that I can multiply the top equation by to get to the bottom equation? Well, if I multiply everything by 2, 2 times y times 2 gives me 2y, right? X times 2 gives me 2x. 2 times 2 gives me the 4. So it's a multiple of it. Okay? If they're multiples of it, they are going to be exactly the same. And a lot of times if you get the same thing here equal to the same thing over here, well, they're always going to be true. It's always going to be the same. So if you run into that situation that the left side is equal to the right, you know that they are going to be coinciding, and you know that they are going to be consistent and dependent. So let's try this one. Parallel lines. I'm going to do the exact same thing. Again, they said that y was equal to this. So I'm going to take the other equation, which is negative 2x plus whatever y is equal to negative 2. I'm going to put in what y was. Y was that, so I'm going to put in 2x plus 2. Okay. Now, as I do the math on this, add like terms, I got negative 2x plus 2x. Well, that wipes each other out, correct? So that ends up with 2 is equal to negative 2. Is that ever possible? No. And because that's not possible, this would be no solution. So we end up with parallel lines, lines that have no points in common, inconsistent, no solution. So there are three possibilities when we have equations. They either cross and we have one solution. They are the same lines, so all solutions are the same. Or they're parallel lines and they have no solutions. So, what about this one? Okay, this one's just flat out ugly. 3x plus 2y is equal to that. 4x minus 3y is equal to the other one. Now, there are other ways of doing this, and quite frankly, that's what you would use. It's what's called elimination with this one. It'd be a lot easier to deal with. The common variable, same opposite sign, same coefficient. But we're going to do this one. So which one should I work with? It absolutely doesn't matter one bit. So I'm just going to take the top equation, which is 3x plus 2y is equal to negative 3. I'm going to pick a variable to solve for. It honestly isn't going to matter a whole lot. So let's say that we solve for, I'll solve for x. So that means that I'm going to subtract 2y to both sides, subtract 2y to both sides, and I end up with 3x is equal to negative 2y minus 3. Divide both sides by 3, divide both sides by 3. And so I end up with x is equal to negative 2y minus 3 over 3. Okay. It does not matter one bit. Do I know what x is? Yes. I go back up to the other equation, and I have 4. Well, what's x? X is going to be that stuff. So that would just put in the negative 2y minus 3 over 3. And the rest of the equation, which would be minus 3y, is equal to 13. Now, there was a while ago that we had talked about, well, I don't like messing with fractions. I want to get rid of fractions. Okay? Is there a value that I could multiply through by to get rid of that denominator of 3? And the answer is yes. All I would do is multiply the entire equation through by a 3. So when I do 3 times this first bit, it disappears and I'm left with 4 parenthesis negative 2y minus 3 there. Then I multiply it by the next thing. Well, that's just going to be minus 9y. Then I go and multiply it over here. So that turns out to be 39. Got rid of the fraction. Unless you like working with fractions, you can keep it there. But this makes life a lot easier. So whatever your denominator is that you get down here, multiply everything through by it. It'll wipe it out here right away, so you don't have to worry about it. So now, I'm going to go through and solve this thing out. So I got distributive property here, so that's going to give me negative 8y over here minus 12. Okay. Minus 9y is equal to 39. Okay. Add like terms. I got like terms here, like terms over there. So that's going to be negative 17y minus 12 is equal to 39. Plus 12 plus 12, negative 17y is going to be equal to what? Oh, that looks like what? 51. This is already looking ugly, isn't it? Okay? So, divide both sides by negative 17, divide by negative 17. Y is equal to, now, just for the sheer luck of it, I'm going to check 51 divided by 17 because I'm just hoping it comes out to be a nice number. And how do you like that? It turns out to be a nice number. You can always go and check just to see if that's going to happen. So y turns out to be equal to negative 3. Well, that makes life a little bit easier to work with, right? So now that I know what y is equal to, I can take this here, put it in over here. So that means that x is going to be equal to negative 2 times whatever that is, minus 3 over 3. So what's y again? Negative 3. So x is going to be equal to, work it out, 6 minus 3 over 3. So that gives me, let's see, x is going to be equal to, oh, that'd be 3 over 3, so x is equal to 1. So that means the answer for this one is going to be 1 comma negative 3. Now, one of the warnings that I'm going to give you guys with this is those of you that like just turning in homework with answers and not working it out, it's impossible. You can't do this in your head. I can and I don't want to. Okay? Writing it out is a heck of a lot easier than trying to do anything else. Yes, there are little shortcuts that you can do in the arithmetic, but write it out. Okay? Questions on this? So, now, how are you going to apply this stuff? Well, it says this table shows the increase in the population of Maine and Hawaii in 2004 to 2005. If the population continues to grow at this constant rate, in what year will these two states have the same population? Okay. It's not that big of a deal. We got numbers here, we got numbers here. Now, it tells me that it increases, that Maine keeps on going up by 4,252 every year, correct? So if I want to, I can write out an equation that looks like this. Maine is going to be equal to 4252, and I'm going to put in my x here. Why? Because that's how many years it's growing by the years, correct? Plus, how many did it start off with? Well, it doesn't matter which one of these numbers I use. I'm just going to use the 2005. Plus 1, 3, 2, 1, 5, 5. Because if I add another 4,252, I end up getting 2006. So what about Hawaii? Well, Hawaii would look like this. Hawaii would be equal to 12, 3, 5, 4, x plus 1, 2, 7, 5, 1, 9, 4. Okay. Now, the question is here, what year? Well, to be honest, we want these things to be equal to each other, right? We want this question, when is Maine equal to Hawaii, correct? Isn't that the question we want? So could I just go and set these equal to each other? Could I go and say that 1, 2, 3, 5, 4, x plus 1, 2, 7, 5, 1, 9, 4. I want to know when that is going to be equal to 4, 2, 5, 2, x plus 1, 3, 2, 1, 5, 0, 5. Substitute one in for the other. So now we just go through and do the math. So I'm going to take 4252x here minus 4252x here. Subtract 1275194. Subtract 1275194. And grab the calculator because I am not going to deal with those large numbers. Why should we? If it works. So if I go and take 1, 2, 3, 5, 4, subtract off 4252, what do I end up with? I end up with 8102x is equal to. That's the other side. So I get 132. Anyhow, continuing on here. So I got 132,505 minus 127,5194. And I end up with, let's see, it's going to give me 46311. Is that right so far? So, now what's the last thing I got to do? I got to divide. Why do my numbers seem off there? Because something doesn't, actually, keep going from there. So now I'm going to divide by what? 8102. And I end up with 5.7. Something is off. It's supposed to be 6.7. Sometimes when you got those large numbers on there, you got to make sure that you write things down right. 1, 2, 3, 4, 5. 194. So I put that one in there. 132. 505. 127. 5194. 46,311. Yep. Over here, did I get that right? 12,345. 8102. Yep, that's what I get over here. Actually, I think they got the error because they come up with 54,316. Oh, I know what they did. They went and used the 2004 numbers. I used the 2005 numbers. So x is equal to, it always helps to pay attention to that. So we end up with 5.7 years. So I'll use the 2005 numbers, so that means in 2010 is when that should happen. Now, if you were taking a look in the book and following along there, it said that it came out in 6.7. They used the 2004 numbers, which would be here, which would be 6. So I'm going to give you a couple of minutes here, and I want you to do this problem. Okay. Now, when you're working on these things, please write everything else. So if you get stuck, I can go at trying figuring out where things went wrong. Now, I do want you to understand that you may have started off a different way than I did. So, does anybody have a choice for me? Which equation that they want me to work with, first or second, and which variable? And solve for? Okay. So we'll take y plus 3x is equal to negative 4. Solving for y gives me this. Okay. So that's where I start with to begin with. And like I said before, on this equation, y is the simplest thing to solve for. Don't have any other coefficients. So now with the other equation, I've got 3y minus 2x is equal to negative 2. I am going to replace whatever I see for y with this. Okay. So it ends up looking like this. 3 parentheses minus 2x is equal to negative 2. Put in my, whoops, sorry. Okay, erase it. Minus 3x minus 4. Okay? That's all I'm doing. Wherever I see the y, I replace it with that. Okay? So now, I go through the rest of this. Distributive property, so that gives me negative 9x minus 12 minus 2x is equal to negative 2. Adding the like terms here and here. Negative 11x minus 12 is equal to negative 2. Add 12, and I get negative 11x is equal to 10. Divide by negative 11, divide by negative 11, and I get x is equal to negative 10 over 11. So, did anybody else get negative 10 over 11 for x? Good. So, we're on the right track. Takes a little bit to do. Now that I've got this piece of information down here, I want to put this in for x right there. So that means I'm going to have y is equal to negative 3 times x, whatever x was, minus 4. So what was it? Well, that's going to be negative 10 over 11. So now, work it out. Y is going to be equal to, we could put that over 1, so that gives me 30 over 11 minus, well, we know that this has to be 11, right? So 11, 44, right? 11 times 4 is 44. So I get minus 44 over 11. Y is going to be equal to 30 minus 44 is negative 14 over 11. So that means the final answer for this thing is going to look like this. Negative 10 over 11, comma, negative 14 over 11. As I said, using this method, it is impossible to get an answer without actually showing the work for it. So, any questions, anything that you want me to see or want to see and have thoughts about that you don't understand why I did that? Yes, I know it's an awful lot of writing and an awful lot of work, but it's the way it happens. So, let me give you this one, and I want you to work on it for a few minutes. I'll go. All right. I assume that since we see that y is equal to that, we should substitute that into the first equation, right? That's the easy way of doing it. So, we've got the first equation, 3, whatever y is equal to 12 minus 6x. So I put the other one in, which is going to be negative 2x plus 4. Distributive property. Well, let's see, that gives us that negative 6x plus 12 is equal to 12 minus 6x. So if I keep going with this, if I add 6x here, add 6x here, subtract 12, I end up getting 0 is equal to 0. So, is there going to be a solution? Yes. This is consistent dependent because they are the same equations. Are they multiples of each other? Multiply by 3 here, multiply by 3 there, multiply by 3 there. Did I get the same thing on both sides? Well, is this the same as that? Yeah, it's just in a different order. So, Assignment is going to be due at the end of class tomorrow.